Let's take a look at some other problems. Here, they're just giving you the numbers for Pythagorean theorem. So plug it in, it's pretty easy. Number 8, that's fractions. Feel free to skip it. Feel free to skip the fractions. Here's some different kinds of problems for Pythagorean theorem. Take a look at number 9. That's a commonly missed one. Okay. If you look at the triangle completely, it's not a right triangle. Okay. So here's the problem, okay? Like I said, this is not a right triangle. If these are my 3 angles, none of those is a corner. None of them are a right angle. But what we can see here is that this triangle has been split down the center, and we have these 2 marks. And since it's a single mark in each of these, that tells us it's the same, all right? So what they've done is they've basically taken this triangle, cut it exactly in half, which makes right angles on both sides, okay? And since we know that, we can use, we're trying to find the height of this triangle, we can use half of it, half, which is the right angle, the right triangle part of it, to figure out that height, okay? The trick, though, is we're not going to use 10. 10 does not represent the bottom of the right triangle. The right triangle is one of these sections, okay? So if I were to redraw it, it would be like this, okay? And so since we know the full thing is 10, it's cut in half, making that 5. So now we have 2 sides of a right triangle, finding the third. So go ahead and pause it, finish this problem out if you haven't already, and then check back for the answer. All right, so if you're back, it's Pythagorean theorem. We have 2 sides, we're missing the third, and we plug them in. Decide which sides do we have, okay? Here's the right angle. We have 1 leg, but we're missing a leg. So we're gonna be missing one of these. Here's our hypotenuse. It's got to be C. So fill everything in and work the problem. A squared plus 25, that's 5 squared, equals 13 squared of 169. Subtract the 25. A squared equals 144. Last step, square root, A is equal to 12, okay? So we would know the height of that is 12. That's a commonly missed problem, though. Feel like I've been going a little bit. Probably going to be a long video. Okay, let's do a, here's some word problems. Plenty of worksheets. They've got some decimals in them. Just use your calculator. Let's see. I'm just looking at all the worksheets I gave you. I gave you a lot of practice, okay? All Pythagorean theorem. There's some word problems. There's some more word problems. These are a little bit easier. So if you're trying to do some word problems, maybe start with these. They have a picture to go with them. And then another pretty basic worksheet. Okay, so some of these, a lot of this is repeat. It's just giving you plenty of practice. So let's do a couple word problems, and then we will we'll end there. Okay, so number 1 on this sheet, 2 sides of a right triangle are 8 and 12. Find the missing side if these are the lengths of the legs. That's A. And B, find the missing side if these are the lengths of the leg and a hypotenuse. We're not going to do that one. I like it though, because you're using the same two numbers and you're going to see how setting them up differently gives you a different answer. So, but I want to do one more with kind of a contextual problem where you got to figure it out. So number 2 is pretty similar to one you see on the practice test sometimes. Could be one you see on the real HSE test. So let's take a look at that. The foot of a ladder is placed 6 feet from a wall. If the top of the ladder rests 8 feet up on the wall, how long is the ladder? Okay, so the foot of a ladder is placed 6 feet from a wall. When I'm doing story problems, and I really think it's a good habit to get into, you got to make sense of the problem, okay? If that means you draw a picture, you draw a picture. I like to draw a picture, especially with these. So I have a wall. Okay, the ladder is 6 feet up on the wall. So here's the ladder kind of going down. What I know is that's 6 feet up on the wall. Oh, I'm sorry, read that wrong. 6 feet away from the wall, and it's 8 feet up on the wall. The question is, how long is the ladder? All right, let me show you what I did here. Okay, so here's my wall, basically. I drew a wall, and then I knew there was a ladder that was leaned up against it. So here's my ladder. And you don't have to go into that much detail, but I'm just trying to make it obvious to you. So what they said is that the ladder was 6 feet away from the wall and that it was 8 feet up the wall. Now, this looks like a 90-degree angle, and we can assume that it is a 90-degree angle because when we build walls, we build them straight up from the level ground, okay? And so that's a 90-degree angle. So here is our right triangle. Notice we have both sides of the right angle. So we have both legs, which if you remember, the legs are A and B. So 6 and 8 are our A and B. 6 squared plus 8 squared equals, this is the hypotenuse, okay? It's across from the right angle. That's what I don't have. So 6 squared, 36, plus 8 squared, 64, equals the side squared that I don't know. Combine, 100 equals C squared. Last step, obviously it's not a 100-foot ladder. Last step, square root. Square root of 100 is 10. So that would be a 10-foot ladder. There's an example of Pythagorean triples, 6, 8, and 10. You'll probably see that come up a lot, 6, 8, and 10. 3, 4, and 5. 5, 12, and 13. Okay. Couple more. I'm sure I'm going a little over on time. All right, I like this one. We'll make this the last one, okay? If you have questions about any of these specifically, get a hold of me and we can go through them. We can go through them on the phone or Zoom, or I can write it out and send it to you in email, something like that. So number 5 says, Scott wants to swim across a river that is 400 meters wide. He begins swimming perpendicular to the shore he started from, but ends up 100 meters down the river from where he started because of the current. How far did he actually swim from his starting point? So again, I really need to draw a picture of this situation and figure out what's going on, okay? So I know there's a river. So I'm going to draw the river. I know that the river is 400 meters wide. So I'm going to go ahead and draw across my river that is 400 meters wide. Let's see if I can make this bigger. So you can see my river. I just drew across its 400 meters. He begins swimming perpendicular to the shore. Okay, so here's the shore. Perpendicular means straight across, okay, at a 90-degree angle with the shore. But he ends up 100 meters down the river from where he started. So let's say he started here. He started swimming this way, but really he ended up 100 meters. When he got to the other side, he was 100 meters down. From where he first started. How far did he actually swim from his starting point? Okay, so let's take a look at that. Here's the river. Okay, that's just going to be a common thing, I guess. Sorry. Here's the river, 400 meters wide. This is his starting point. He swam, but because of the current, he ended up down here. Okay, this is where he actually landed on the shore, which was 100 meters from where he started, basically. All right. And the question is, how far did he swim from his starting point? So I don't know if you can tell, but there is a right angle here. So there's the right triangle. We have the two sides of the two legs that make the right angle. All right. So we have A and B again. 400 squared plus 100 squared equals C squared. 400 squared is 160,000. 100 squared is 10,000. So it's 170,000 is C squared. Last step, square root. So square root of 170,000 is 412.3. So even though it is 400 meters wide, he swam 412 meters because of the current. Okay. So that's kind of how you do that. I think that's going to be the last one we do. I've probably been going too long. There's enough here that if you get stuck on one, you can skip it and go to some others. Okay. So I definitely think Pythagorean theorem is going to be on the test. Something you should know how to do. The main thing is knowing when to use it, which is when you're missing a side of a right triangle. And then how to use it, of course, just plug those in according to which sides you have, okay? So good luck. Let me know if you get stuck, and I'll see what I can do to help, okay? Thanks for watching.